welcome to Cherry Pie Math. This video is going to go over exponent properties, specifically the product and the quotient property. Before we begin, you should know what it means to expand an exponent or an exponential expression, and you should know what negative exponents mean. If you don't feel good with either of those concepts, I'll link a video here and you can go watch it, but we are going to kind of review them as well in this video anyway, so that's kind of up to you. Okay, so let's look at the bell work today. Or like just kind of get our gears turning. So we have an expression 2 cubed times 2 to the 4th power. So I want you to pause the video and think about what the exponent is when you put it all together and where do you think that number came from? So pause the video, think about it. Okay, so hopefully you paused the video and you looked at it. If not, you at least kind of thought about it. So I'm going to answer this a little bit later, but we're going to be able to see different properties that occur because exponents are built off of multiplication. So let's first talk about what is an exponent property. So an exponent property is a rule / shortcut we can apply if certain conditions are met. And like I said, we're only really going to go over two properties here, the product and the quotient property. So first, let's talk about the product property and what conditions have to be met for this to happen. So in the bell work, we saw that the two exponents added together to make the new exponent. So if we look back at the bell work here, we got 7 because 3 plus 4 is 7. So when we multiply two exponentials with the same base together, we add the exponents. So this is because exponents represent the amount of times we multiply the base by itself. So we are just adding on more times to multiply the base. And this also applies to negative exponents. And so, because when you expanded it out, you were able to see, okay, we had 3 2's and then 4 2's, right? Because you're just multiplying it out. 2 times 2 times 2 was 2 cubed, and 2 times 2 times 2 times 2 was 2 to the 4th, and then all together you just have 7 2's because you're just multiplying them all together. So let's do some examples so it makes more sense. So in the first one, you have 3 squared times 3 squared. If I expand it, it's 3 times 3 times 3 times 3, which is just 4 times, or 3 to the 4th, and we can see that 2 plus 2 is just 4. Same idea here with 4 squared times 4 cubed. I have 4 times 4 times 4 times 4 times 4, which is 5 times. Or in the next one, if I just added the exponents, because you can expand it if you want to. And some students do, they like the product and quotient and all these properties just kind of go over their head. So it helps them to write it out, which is fine. It's a little bit less useful to write it out if you have like really, really, really big numbers. But when they're little numbers like this for the exponent, it's fine. 6 plus 3 is 9, so this one would be 2 to the 9th power. Next one, we have a negative exponent, but the same rule applies. So remember that negative exponents don't really mean you turn anything negative, it just becomes a fraction. So if I was to expand this out, I'd have 4 times 4 times 4 times 4 times 4 times 4 on the top, because that's 4 to the 6th. And then I'd have 4 squared on the bottom, or 4 times 4, but if we remember, a fraction is really just division, and so you would be doing, you would just be able to cancel out 2 of those 4's because they divide out, and so that cancels out the multiplication, and so we end up with 4 4's, or 4 to the 4th, which is what we would have had if we did 6 plus negative 2, because remember, adding a negative is just subtracting. So same idea in the next one. The base is the same. Yes, we don't know what it is, it's just a variable, but you can still add the exponents because you're multiplying and the bases are the same. So 7 plus negative 4 is 3, so the answer would be x to the 3rd power. And like I said, you can expand that if you want to. And last but not least, we have a to the 13th power because 8 plus 5 is 13. Okay, so now let's talk about the quotient property. Like we saw with negative exponents, when we put a number on the bottom of a fraction, we are really performing division, right? And so since division cancels out multiplication, we subtract the exponents. We divide two exponents with the same base. So I'm just going to write all that down. Okay, so let's do some examples for that. So it's really similar to the product property. Just remember that if you're multiplying, you add the exponents, and if you're dividing, you subtract the exponents. So in the first one, if I wanted to write this out, I'd have 6 5s on the top, so 5 times 5 times 5 times 5 times 5 times 5. And on the bottom, I've had 3 5s, so 5 times 5 times 5. I cancel out 3 of them because that's what matches on the top and the bottom. And then I'm left with 3 5s or 5 to the third power. And that is my simplified answer. I could simplify it more to 125 actually, and you should if you can, but sometimes your teacher might just be looking for the property usage, and so you just subtract the exponents. And the next one, I have 4 10 to the 4th divided by 10 to the negative 9. This one's a little bit different. So if I was to expand it out, I'd have 4 10s on the top, but then on the bottom, I have 10 to the negative 9th already. It's still negative because it's division, and so that's just on the bottom, but I can't have a negative exponent for this to work. And so I'd actually have like a fraction inside of a fraction. And what happens when you do that, if you can do like copy dot flip or like reciprocals to check out this math, I guess. But really what happens in the end is all of the stuff on like the double bottom actually reverts back to the top. So we end up putting all of those 9 10s on the top. So we'd have 13 10s total. Another way to think about it with the quotient property is 4 minus negative 9. And so then you'd have a double negative, and then you would have 13 anyway. The next one, 7 to the 8th divided by 7 to the 8th. 8 minus 8 is 0, and anything to the 0 power is 1. And that makes sense because anything divided by itself should just be 1. And the last one, I have 8 to the 4th divided by 8 to the 8th. I actually end up with 8 to the negative 4th. But when we simplify, we have to remember to make sure there's no negative exponents. So if we have a negative exponent, we just have to change it back to a fraction. So my answer would be 1 over 8 to the 4th. So after you combine the exponents, remember to simplify, whether that's expanding it. So like if I had 5 squared as my answer is really 25. Or if I have a negative exponent, I have to just make sure I put it back in a fraction. So what about negative exponents? When you have negative exponents, you just have to make sure that you change it, like I said, back to a fraction at the end. Otherwise, it's not considered a complete answer. I'll be able to see that you were able to do the math, but just formality, and there's sometimes like math has just weird formal rules, and one of them is that you can't have negative exponents in your answer when you simplify, so you just put it back into a fraction. Okay, so in case you were too bored by this video, I made this little chart. You can pause it and write it all down. And hopefully that helps you with your exponent properties, and good luck.